object storage. It's just the best. Welcome to the second video in our series explaining SymplyPERIFERY, our S3 native scalable storage system. Within SymplyPERIFERY, our unit of content is the object. But what is object storage? In traditional file systems, data is stored in a hierarchical structure. You put a file inside a folder, inside another folder, inside another folder, and your applications have to go through that structure to find what they need. With object storage, the structure is flat. Think of it as a table. Onto our table, we place objects. These can be videos, photos, music, documents, Maya files, Premiere Pro files, apples, basically anything you need to work with on your computer. These objects are kept with a set of metadata, like a post-it note that describes the object. And along with that, there's a unique identifier assigned to the object so you know its name, Apple 001. So we have a table with a bunch of objects on it with labels. Great. At the end of the table is a journal. Now, this is a small file that contains a list of objects and the unique IDs and their corresponding metadata. Using the journal, you can search for some metadata, green apple, and find all the object IDs associated with that data. Then you just grab those numbered objects from the table. This is what makes object storage so powerful. Descriptive items in a flat structure so they're not lost. Slow for a few pieces of data, but incredibly fast at scale. In SymplyPERIFERY, our table is a disk. Many disks make up a node, and many nodes form a cluster to create one massive flat surface on which we place our objects. There are no traditional file systems inside of SymplyPERIFERY. File systems just aren't robust enough or fast enough to scale into the hundreds of billions of objects. Physically, an object stored in SymplyPERIFERY is a contiguous sequence of bytes on a raw disk, not dissimilar to how data is written to an LTO tape, i.e. in a linear fashion. Data streams written to the disks, either segments of erasure-coded data or replicas, more on that later, don't worry, are stored in similar ways. Consisting of two parts, the data and the metadata, these are written strictly once and always remain physically encapsulated together. The metadata part contains two classes of headers, those that drive SymplyPERIFERY behavior, and custom ones that are inserted by an application. Objects are written to the disk on a single writing front of free space. Deleted objects are simply marked as such, and space is reclaimed asynchronously afterwards by the health checking process. More on that later as well. When objects are written, a record is also added to a small journal in the front section of the disk. Remember our table. This makes the disk totally self-describing. At boot up time, that journal serves to repopulate an extremely fast RAM index that holds pointers to where a given object is located. Using our table example, we have a big directory at the front and you can look in it for any object you want. That big directory is made up of the journals kept on all the individual tables. This explains one of the most surprising and appealing characteristics of the SymplyPERIFERY architecture: the capability of knowing within a couple of milliseconds on which node, disk, and sector a given object is located among hundreds of billions of others in the cluster. Just try looking for one specific apple in an entire greengrocer's. Armed with this knowledge, SymplyPERIFERY can position the right disk drive arm at the front of the object and read it from the disk, often in one single I/O operation. Executing a comparable operation on a traditional file system typically takes tens of IOPS. This way, importantly, the response time to access an object is entirely independent of the number of nodes, or the object count, in the cluster, which is truly exceptional. This unique approach, combined with our parallel architecture, means that performance from only a handful of nodes can scale rapidly into gigabytes per second. But what do we mean by parallel architecture? Think of it like straws in a glass. The more straws you add, the more data can flow into and out of the glass. In a traditional file system, there's only one straw. The client side has to break up the files and send them in lots of smaller parts to the storage. SymplyPERIFERY, on the other hand, uses many straws to suck up all the parts at the same time and stitch them back together. In this manner, hundreds of terabytes per day can easily be uploaded to the cluster. So, SymplyPERIFERY is an object store with a parallel, linearly scalable architecture. Add more nodes and you get more storage and more speed. This is a feature that's pretty unique to our solution. Okay, that's enough about object storage. I'm going to go and eat this. In our next video, we're going to talk about maximizing capacity on disks and how SymplyPERIFERY uses those disks in a raw fashion. Until then, don't forget to subscribe to the channel and ring the bell for updates. See you in the next video.